go. Recording, excellent. We'll see if this works. Or if I can find the recording again, but surely if it's recording, it's putting it someplace. Okay, so measuring distance off a position graph. You remember how this goes, or maybe not, where your position is on the y-axis, okay? So you're just saying like, how much have you walked? So like the up and down motion, that's saying, that's your distances, okay? So like walking from 0 seconds to 30 seconds, the person went away in the positive direction 200 meters. Okay, so it went up. But distance actually doesn't care about up or down. It's just distance. Okay, so there's 200. If they continued walking, they went another 300 meters. And when it's flat, they're not moving position. So that doesn't add anything in. So it's like the sum of all the movements along the y-axis. That's distance. Okay? And you guys at home, I'm not tracking the chat because I can't, because I'm like 5 feet away from you. So you're gonna have to, if you have a question, you gotta unmute and yell, okay? That's true for you guys here too. Okay, so far this is review. You know, and then this little bit down at the bottom, and this adds up, like the total distance traveled would be this. Okay? So questions I might ask you will be like, where was the position at 2 seconds? Well, this is just regular graph reading. At 2 seconds here, the position was 10. Okay, that's just saying at what x, at this x, what was y? Okay? Not worried about these. Okay, total distance, you would add up all the movements along the y-axis. So here, moving from here to here, that would be down 10. Moving from here to here, that would be another like 16. From here to here, that would be another 16. All right, so that we did before. But, okay, here's what I did not say explicitly before. That I just realized. You measure displacement off of a position graph too, but it's different because displacement doesn't care how far you went on your path. It matters where you ended up. Okay, so if we wanted to look at point A and point B, okay? So the displacement, you can think of final position minus initial position, and whatever these are depends on what you said. It's not necessarily the beginning and the end of the graph. It could be like, here's the position, the first position, here's the second position. For right now, I'm saying here's the first position, here's the second position. Okay? So what you do is you look at what was the difference in y. What was the difference in position between this point and this point? And it's this. It's this little bit, which is, what is that? I might be blocking it. I heard it. What is it? 200. Okay? And it's 200 down. Yeah, you could say in the since it's negative on here, if it were north-south, it would be 200. Yeah, I'd say 200 negative. Yeah, negative 200 is the displacement because it's a vector. Remember how we talked about vectors are things that have size and direction? So displacement is like that because it moved from here to, well, it's really from here to here. Okay, so that's negative 200. Okay, so speed, let me see if we did everything on this one. Yep, so that's the motion of an object. Oh, okay. There's another thing I wanted to make sure to show you. Oh, like this. Okay, so you guys see these? I I should probably link this to you. Because ordinarily I would hand out papers and we would go over all the problems and you would write the answers to problems on the paper. I haven't really figured out how to do that in virtual land when I don't know that everybody has a printer. I had thought about this like 2 months ago.
They can make a copy of it.
Well, they could if they can print from home. And they could make a copy, but then you'd have to write on it, like type on it, which is, especially like for calculation, it's not my favorite. Although you guys probably have like screen, you're more tech savvy possibly than I am. Okay, so if you're looking at displacement time graphs, okay? So the ones that have constant velocity, so that's where, oh gosh, there's so much to talk about now, it's all related. So remember that velocity is, well, I didn't even say that. Velocity is displacement over time. Maybe I should do that first. Okay, so speed is here. So like, a thing that I have just done is kind of like a throwaway thing that I assume you can do is if I give you time and displacement, I'm sorry, time and distance, you'll be able to give me speed, okay? Because that's just like, plug it into the equation, not doing anything. So I'm not going over that a whole lot because I assume whenever we've done that, people kind of have that. Especially if I don't have to, I don't make you manipulate the equation or anything. Okay, so if a car goes 50 meters in 10 seconds, its speed is 5 meters per second. Okay, because it's 50 divided by 10 is 5. Okay. Yeah, I'll do that before the other thing. Okay, so you can read speed off of a position and time graph, okay? Because speed is distance divided by time, then if you look at distance divided by time, that's the same as rise over run. Oh, I split this around. So if you manipulate this, then you get distance equals speed times time, which is like y equals mx plus b, and the m is the slope. Okay, so speed is the slope of the line, okay, at that time. So like here, slope is 0, speed is 0. Here, speed is pretty steep, so it's pretty big. Here, the slope is lower. It's in the negative direction, but for this, we don't care. Okay, so this goes in the negative direction, but the slope is smaller, so the speed is small. Yeah.
The speed can't be negative, right?
Speed can't be negative. Velocity can be negative. And you can have a change in speed being negative. Like, in like your everyday non-science life, it's easy to kind of mix up acceleration, which we haven't talked about formally, and speed. But yes, speed can't be, I mean, think about like, if you're driving your car, the speedometer only goes to 0. It can't go negative because it's distance divided by time. Negative distance has no meaning. Now, if it's displacement, you can have a negative displacement because that just means in the negative direction. But speed has no direction. So there's no meaning for negative. I mean, some things can have a negative, like temperature, and not have a direction, but for speed, there is no meaning. Okay. Do you guys remember this? Are you okay with this? I've seen 2 actual people in the computer, 3 actual people here. And I can't tell anything from you. Pauline, are you okay? Okay, this is all right. You guys okay with this? Okay. Okay. So that's the slope. That's the magic thing to remember, is that speed is a slope of this kind of graph. Okay, so steeper slope means greater speed. Okay, here's where we're getting to where I wanted to check. Okay, so if you've got distance and time graphs, if you think about what these curves mean, okay, if it's a straight line, that's a constant speed, okay, because the slope is unchanging, okay? Straight line, y equals mx plus b. There's only one m. M doesn't change with a line. Okay, this is constant speed, but it's 0, not moving. This is constant speed in a different direction, so it's just getting closer to the reference point. Okay, it doesn't mean it's getting slower because the slope is the same, the speed is the same the whole time. The direction for speed does not matter. Okay, for this one, the slope is changing all the time. Okay, so that means the speed is changing all the time. And this one, it starts out steep, so remember steep equals fast, less steep, less fast, less steep, even less fast, until it gets to 0, stopped. Okay, so this one is getting slower and slower. And if you want to think about this, you can draw, you guys know what a tangent is? That does not help you. Okay. If you draw, well, if you draw a dot and then a line that goes right through that dot, that's the slope at that particular point. You don't really have to do that. You don't have to know that. If that makes it easier, good. If it doesn't, forget I said anything. Okay. Okay, so if we're doing that, then let's go to this one again.
This is Mindy.
Yes.
For the last line that you showed us, is that gonna are we supposed to find? Is it gonna be on the test? Are we supposed to find the slope on the test?
Yes, you will have to find a slope for this one. You will have to find a slope for things like this. Or things like this, like if I say, what's the slope here? You know, I could say like, oh, at a point right here, what's the slope? What's the speed? Okay? That is one of the things. Okay. So this one, oh, the coming towards, going away, staying still. Okay, so for this part of the, and these overlap a lot, these standards. So that's why I'm kind of jumping around. But for this one, okay, so this one is going away. You can tell because the displacement is going up. Okay, so it's going away. So which ones have constant velocity? The ones that are straight line. That's exactly. Okay, ones that have straight lines. So this one, and this one have constant velocity. Which ones have changing velocity? Yeah, the last two, the ones that don't have straight lines. Okay, it could also be if there was one like, it was like this, it went like this, that also does not have constant velocity. Even though it's a series of straight lines, it's not constant over the whole graph. Okay, so anything where it's not just a single straight line, that's not constant velocity. Okay, which ones have positive velocity? Ones that go up. So like this one has positive velocity. This one goes from 0 to positive. Oh, I'm sorry, this is velocity. Oh, dang. I meant to do this for speed. Shoot. Because that's what we were just talking about with speed ones. So we haven't gone into velocity yet. But actually, it's the same because these are, I was wondering why that was displacement. I didn't read this on here. Okay, so, and I wrote this. Okay, So positive velocity, it is still going up. Okay, which ones have negative velocity? If they go down, like this one, which ones have increasing velocity? So that means like going faster and faster. So this one, if it's getting steeper and steeper, then it's increasing. Just remember, steep equals fast, less steep equals less fast. And you can derive the rest of it from that. Yeah, we're gonna have to practice this more. Okay. So that's that one. Can you calculate velocity off of a time versus position? Okay, so this means, well, let me see, because we didn't even talk about displacement. Yes, we did. Yes, we did. I just changed some of these slides. Okay, so if displacement is like this, okay, so it's the difference between here and here, so you only look at these 2 points, then that's how you find velocity. So like this negative 200, if you were figuring out velocity from this, so okay, here we go. Let's do this, just to introduce this more. So then velocity, remember, is almost like speed. It's speed with direction, okay? But when you're calculating it off a graph, which is a little bit different because you're getting the displacement off the graph, you just have to define it more clearly. Because before, I was just saying like, oh, if you're doing this in like a story problem where you don't have a graph or anything, then they're not going to tell you to calculate the displacement. Then distance and displacement are sometimes the same. Okay? If you're just going at a straight constant velocity, distance and displacement will be the same. Okay? So it's almost the same, but there are some times when it's not the same, and those times are when you're reading it off a graph and the velocity changes. Or I'm sorry, it's not a constant speed, constant velocity. Okay, so to compare, speed equals distance divided by time, velocity equals displacement divided by time. Okay, but the only time that you'll care about that this is displacement is if you're reading it off a graph. Okay, so let me show you how to do that. Oh, velocity is a vector, yeah. Let's see if I put this here. Okay, so here, I'm going to talk about average speed and velocity at the same time, because we just talked about how to do velocity, how to do speed. But if you're doing average, so because speed will be the slope of any segment of there. But what if you wanted to get average speed? Okay, so average speed is the total distance over the total time.
This says Mindy.
Yeah.
So speed and average speed are not the same thing.
They will be the same thing if your graph looks like this, if this is time and this is position. If it's just a straight line forever, they're going to be the same because your distance and your displacement are going to be the same. Okay, so like for this section here, so like if this is, I'm looking at point A and point B. Okay, this is position. So the displacement is from here to here. because it's the position here and position here, but that's all that you did. So the distance is the same in this case. Okay, but if you have a different path, where it's going like this, okay, there the displacement is still this value here, this value, but the distance is going to be, you know, this value plus this value plus this value plus this value. So the distance, and you can see it traveled a much more long path. So the distance is bigger if you've got a wiggly line. If you've got a straight line, they're the same. Okay? Just like for anything with an average, if all your values are the same, then the average is the same. The average is the same as the regular values. If you've got a bunch of values, then if you average it, the average is going to be different than any particular value. Does that make sense, or is that, do you need some more?
It makes sense.
Okay. Okay, so this is a wiggly line. So distance and displacement are not going to be the same. Now, if I'm looking just from here to here, they're going to be the same. If I'm looking for, well, except that displacement has a direction. Okay, just like velocity has a direction. So like, let me make that point a little clearer. So looking from here to here, then the displacement, I'll go up with the distance, equals, well, it's 500 minus 100, equals 400 meters. The displacement is negative 400 meters. Okay? Because it matters to displacement that it went in the down direction. Okay, so the value, if it's straight, is the same, but it'll have a direction. Okay? And the direction in this, it could be north-south. Because we're doing this in math, we're calling this direction positive, this direction negative, because we know how to deal with that. Okay, a lot of stuff, and the coolness of using math and science is also connected to the confusion of using math and science. Because it's like, we're taking this thing that we know how to deal with, a graph, y equals mx plus b, all that jazz, and we're applying it to a new thing. And so those things mean different things now. So like positive and negative don't just mean positive and negative, they're a direction. Like a physical direction on the earth or in space. Okay, so that's the thing. Now, if we're figuring out, so average speed from equals 0 to 200, all right. Oh, I think we just did this. I was thinking this would be a different day when I did this. Okay, so the average speed, we've got to do the total distance over the total time. So we're adding up this plus this plus this plus this, which are these things here, which I read up like, okay, this is 200, this is 300, this is 500, this is 175. Add all those up and you get this. So that's your total distance. So your total distance over the total time, so that's 200 is that total time, total seconds. Okay, because that's 200 seconds. So if the average speed is the total distance divided by the total time, And again, where you start on here is up to the problem. You know, it could be find the average distance between here and here. Find the average distance between here and here. Find the, you know, the average speed or distance or whatever. Okay? So then your average speed is 1175 divided by 200, and it goes 5.875. Okay? Now, if we do the same thing with displacement, so if we're doing average velocity, remember, is displacement divided by time. So we don't care about all this up and down jazz. We care, where did you start? Where did you end up? Okay, so how far is the first point from the second point? Okay, and it's like 175. I don't think I did this on slides because I had to go to sleep. Okay, so if this, so displacement equals 175, it's really negative 175 meters. Okay, and then the change in time, or the total time, equals, well, it's 0 to 200, so that's 200 seconds. So then your average velocity is going to be, I'll put V with the arrow, it's going to be displacement 175 divided by total time 200. What is it, 5? 4, 5? Oh, I'm not doing it. I'm going to do it with a calculator. Calculator. I thought I could do that in my head, but I'm just not. Okay, 175, I should be able to do it in my head, but I don't care. Divided by 200 equals 0.875. Okay, 0.875. Oh, and I forgot the thing, this is negative. So it's negative 8.75 meters per second. Okay, so now look at the difference. Okay, so the average velocity is down here, velocity, and the average speed up here is 5.875 meters per second, so almost 6 meters per second. This is less than 1 meter per second. Okay, so it makes a difference. If you're talking about changing direction and stuff, it's going to be different. Of course, because if you're changing direction, you're going to take a longer path than if you go straight. Okay, so displacement, I will give you the equations for this on the test. So you won't have to remember which one is which. You'll just have to know what it means. Okay, so I'll give you like average speed equals total distance over total time. I'll give you.
That makes it way easier, dude.
It's way easier, and that is a standard thing in physics, actually, because there's so many equations. They really just want to know, do you know how to use them? Yeah, I'm not really about memorization. I'm about understanding most of the time. Yeah, Dari.
How'd you get velocity there, like under the?
How do I get velocity? Because I used displacement. So velocity is displacement over time. Speed is distance over time. Okay? Yeah, late. All right. We will eventually play that game when you guys are up to doing this on here. Okay? Well, go to lunch, and I will see you tomorrow. And how do I stop the thing? Recording. Ooh, stop. There it is. Okay.